Hey, Don. Whoa. Hey, Robert. Thanks for meeting us. This is my friend Van.
Hi. Hey, Van. How you doing? Good. Well, Van and Jennifer, I'd like to welcome both of you to the NASA Marshall Space Flight Center and to our historic test area. Van, we understand that you're involved in a bike race, and in any race, it's important to understand where you've been before you figure out where you're going.
Some pretty historic boosters were tested right here in these test areas. The measurements taken here on the ground were used to calculate how the real thing would operate in flight. And what they did was some truly amazing things. You know, it wasn't that long ago that when people talked about something that they thought was impossible to do, they'd say, you've got as good a chance of doing that as going to the moon.
Tranquility Base here. The Eagle has landed.
Bet NASA doesn't hear that one too much anymore.
Yeah, this is really cool, but how can it all be related to my problem with the bike race?
Well, Van, let's take a look at what NASA's doing on its next generation X-plane, which in part is being tested right in this area.
What is an X-plane?
Van, an X-plane is an experimental aircraft built specifically for research purposes. This is one of the latest X-planes. It's called the X-33. This is a 1 to 50 scale model of the X-33, which itself is a scale model of what we're ultimately after, which is a single stage to orbit reusable launch vehicle that Lockheed Martin refers to as Venture Star.
What is a thermal protection system, or TPS?
Name 2 examples of thermal protection.
The X-33 demonstrator will fly and test out the technologies needed to make going into space more common, while making it more affordable and more reliable. It takes off vertically like a rocket and lands horizontally like an airplane. The X-33 is designed with advanced hardware that will dramatically increase launch vehicle reliability. The vehicle is designed to reach altitudes of 60 miles and travel at velocities up to 13 times the speed of sound.
Well, what do you mean by velocities?
Velocity is simply the speed at which something is moving. Try hitting the atmosphere when you're moving at super velocities, and the friction of air molecules with a spacecraft becomes like sandpaper to a match. A thermal protection system, or TPS, keeps a spacecraft from burning up when it comes back into the atmosphere on the journey home.
Okay, so the X-33 has to be protected from the heat, but can TPS be used to shield something from the cold? Like maybe a special outfit for me to wear so I won't freeze during this winter bike race?
Yes, some are being used in down-to-earth applications that keep homes and people protected from temperature extremes, both hot and cold.
Portions of the X-33 TPS systems were tested in a high-performance jet at the NASA Dryden Flight Research Center, and also in special wind tunnel tests at the NASA Langley Research Center and at the NASA Ames Research Center.
I guess I did a small-scale test with my 1-mile bike ride.
That's right, your 1-mile test run was a much more manageable size to test your bike's technologies than the 25-mile race. Because of your testing, you'll be able to change things on the bike and retest more easily.
Now, although the tests were conducted on 2 different types of vehicles, your bike and the X-33, they basically serve the same purpose. They use math and science concepts to overcome challenges. Oh, okay, Van, so tell me, what did you learn from your test run?
Well, that I was exhausted. The bike is so heavy, it was really hard to pedal up the hills.
That's because it took an excessive amount of energy to propel the vehicle. If you multiply the energy that it took to go 1 mile times the 25 you'll need in the race, you can see there's a problem.
I see what you're saying. Hey, let's figure it out mathematically.
Okay, how can a 1-mile bike ride tell us what a 25-mile bike race will require? Enter the world-famous ratio. A ratio is a way of comparing the size of 2 numbers. Let's compare Van's 1-mile test run to the 25-mile bike race he will enter. Now, ratios can be written in numerous ways. Like that, or even like that. Now, all of these ratios are read the exact same way. They're all read 1 to 25. Notice, ratios can also be written as a fraction. Got it? So, for every 1 of whatever it took for Van's test ride, it will take 25 times that in order to complete the race. For example, let's say Van has to pedal on average 1,500 revolutions to go that 1 mile. Can you estimate how many revolutions he can expect to pedal in order to complete the race? One way to solve this problem is to use the fraction ratio and set it up like this. 1 mile to 25 miles equals 1,500 revolutions to what? I mean, what number can you put here so that this second fraction equals 1 to 25? It's easy. If you multiply 25 times 1,500 revolutions, that equals 37,500 revolutions. In order for Van to complete the 25-mile bike race, he will have to pedal approximately 37,500 revolutions. Better him than me. Now, of course, there are other ways to solve this ratio. What method did you use?